Okay, today's lesson is going over balancing chemical equations. Now, chemical equations basically are a challenging topic for many students. And so if you have trouble with this lesson, please review it again, kind of go back over what it is you have troubles with. Feel free to leave me a comment. I'll get back to you on that comment. Or you can see me in tutoring in class and get your question answered there. But let's kind of look at the beginning stuff. Okay, the first thing we want to notice is there is a law that basically says that matter cannot be created or destroyed. It only changes form. Now this is the law of conservation of mass, which basically says that whatever we start with, all the atoms that we begin with in the reactants have to be the same atoms and the same types as we find in the products. Now this was actually understood by our first modern chemist. His name was Lavoisier. And Lavoisier basically kind of came up with an experiment that represented this. For example, if you burn a piece of firewood and you weigh the ashes after the wood is completely burned, you will find that the ashes do not weigh anything near what the firewood originally weighed. So for a long, long time, people thought that you could actually destroy matter. But Lavoisier developed an experiment and many different types of experiments that showed that if we could capture everything, like for example, if we could capture the smoke, if we could capture the steam or the water vapor that comes from the fire of burning the wood, if we could capture all the carbon dioxide gas that comes off of that piece of wood, if we could contain everything within a box and let nothing escape, then the weight would remain the same before and after the fire of the wood being destroyed. Okay? So here are some things to remember. Rules for balancing chemical equations. To balance an equation, we need to make sure that the total number of each element on the reactant side is equal to the total number of each element on the product side. We can only put a coefficient or number before a single element or a compound to help balance the equation. We cannot put a number after an element, add a subscript, or place parentheses around elements to balance the equation. So basically, here are fundamental rules for balancing chemical equations. Number 1, write the formula or elements involved in the equation correctly. Number 2, count the number of atoms of each element on both sides of the equation. Number 3, add coefficients to balance the equation. And then finally, number 4, recount the number of atoms of each element to make sure the number is the same on both sides. Now, these rules and this idea probably seems a little bit strange, or you're not quite understanding it at this point. But as we work through some of the equations, feel free to rewind the video, come back and look at the rules, and see that we follow these specifically as we went through each one of these equations. Okay? So let's start off with our first equation. The first one is probably the most simplest. Okay? So remember, these guys on the left side of our equation, meaning before the arrow, are called the reactants. So basically, they are the different elements or molecules that will combine together, react with one another, and their valence electrons will rearrange and reattach to a different combination, forming a new product. And that leads us to what's on the right side of the arrow. These are the products. Now remember, we said in earlier lessons that this arrow says whatever is over here has to equal what is over here. We normally refer to the arrow when we read the reaction as yields or produces. Okay? So let's look at what's on the left side of the arrow. Well, we have hydrogen atoms and we have oxygen atoms. So we have hydrogens and we have oxygens. Now I'm going to write this same pattern on this side of the line. H and O. Now I want to count up my atoms. Well, this one has a subscript 2, which cannot be changed. Hydrogen is a diatomic atom, meaning hydrogen will never exist by itself, so it's always either attached to another atom or an atom of like kind. So we have 2 hydrogens here, and oxygen is also a diatomic atom. Anytime we have an oxygen out there, it's always attached to another oxygen atom or to some other type of atom. So here we have oxygen by itself, so it has its neighbor, it's another oxygen friend, so it has 2 of those. Now if you notice, these guys get together, they react, and they form a molecule of water. Now if you look, the hydrogen is attached to the oxygen. That's why you don't see an O2 here. But we do have 2 hydrogens. Remember, this subscript only affects the H, okay? Then we have one oxygen, okay? So if we look across from side to side, we have 2's matching the hydrogens, but we have a 2 oxygen and a 1 oxygen over here. They do not match up. So what can I do to match these up? Well, these numbers can never go down, neither can these. So if anything, the numbers have to go up to match each other. So if I look, the hydrogens are okay, but my oxygens are off. So what I want to do is try to get my oxygen over here to go up. Well, I can add coefficients, which mainly mean I can double, triple, quadruple my molecules to get them to match up across each side of the arrow. So if I notice this one is a 1, it can go up. This one cannot go down, it has to go up. So if I put a 2 here, the 2 would change this to a 4. I don't need that, I just need this 1 to be a 2 right now. So I'm going to grab a 2, and I'm going to place it right here in this blank. Now, it did not just change my oxygen, because the hydrogen is attached, is bonded to the oxygen, so the hydrogen is also affected by me putting a 2 here. Basically, I have now 2 molecules of water. Well, so this changes my hydrogen, so now my hydrogen is no longer a 2. The 2 times 2 makes it a 4. Now remember, when we don't see a subscript, we know there's a 1 sitting right there. So the 2 times the 1 is now a 2. Okay? Now if I look across, now my oxygens check out, but my hydrogens are now off. But if I look, I can make my hydrogen over here go up. And the cool thing about that is the hydrogen is by itself over here. And so that simply means that if I put a number in front, it will only affect the hydrogen on this side of the arrow. So, if I want this 2 to become a 4, all I have to do is put a 2 over here. So I'm going to take this 2, drag it right here. Now 2 times 2 is a 4. Now look across. Remember that 2 didn't affect this oxygen because the plus sign separates them. So it only affects this. Okay? So now look across. I have 4 here, 4 here, 2 here, 2 here. That is the law of conservation of mass. What we start with, what atoms and types we start with over here have to equal their types and their numbers on the right side. So if we look back at the rule, we had to write the formula or elements involved correctly. We did that. It was already pre-written for us. Count the number of atoms of each element on both sides of the equation. We did that to begin with. So remember, our original numbers were 2 and 2 and 2 and 1, right? Number 3, add coefficients to balance the equations. We added numbers in front to equal what we needed to. And then we recounted the number of atoms on each element to make sure the number is the same on both sides. We did that. So let's look at another example. Okay, here we have aluminum oxide, and it breaks apart, it decomposes into a simpler reaction. So we have aluminum and oxygen over here. The previous reaction, by the way, was a synthesis reaction. We actually took 2 simple items in our reactants and created a more complex substance. So we created water molecule. So this was a synthesis reaction. This one is a decomposition reaction, and we talked about those in class, so I just wanted to refresh your memory. Okay, so let's look and see what we have. Well, we have aluminum atoms, and we have oxygen atoms. So we need to have those same atoms on this side, so I'm going to write them exactly the same over here so I can go back and forth. Okay, let's count up our atoms. We have 2 aluminum, we have 3 oxygen. On this side, 1 aluminum, 2 oxygen. Okay, so nothing matches. Now, if you notice, my aluminum is by itself, my oxygen is by itself. So it'd be real simple to make this aluminum a 2 just by doing this. Okay, so if I do that, now my aluminum becomes a 2. Okay, that matches so far. But my oxygen is a problem. Let's see what happens with my oxygen. This oxygen is attached to a 3, which basically means that every time I put a coefficient in here, it's going to cause this oxygen to increase by 3. So it'll go 3 if it's just a 1 like it is now. We have an invisible 1 right here, so it's 3. If I were to put a 2 here, it would become 6. If I put a 3 here, it would become 9. If I put a 4 here, it would become 12. So every time I put a coefficient, it's going to increase by a multiple of 3. So 3, 6, 9, 12, and so on. So this number over here is a 2. That means that it will always increase by 2. So 2, 4, 6, 8, 10, and so on. Well, I have to have this side be odd if it's ever going to match this side. So putting a 2 here would do me no good because then it would be a 4. I'll never get this side to be a 4. It will never be an even number. So I'm simply going to skip straight to an odd number. So the first odd number I can get to over here, or I'm sorry, these can be even. Let me change that. A 6 isn't even, and so on, and 12 isn't even. But it'll always be a multiple of 3. So I've got to get this side to become a multiple of 3. So the first multiple of 3 I can get to is a 6. So I'm going to go ahead and drag a 3 right here. Now this oxygen is a 6. Okay? It did not change my aluminum because aluminum was separated by a plus sign. Okay? So now I've got 2 and I've got 6. So let's try to get this one to be a 6. So if I put a 2 here, now my aluminum gets affected. That's going to throw it off, but that's okay. Let's see what happens. My aluminum is now 2 times 2, so that's a 4. And then my oxygen now is a 6. 3 times 2 is 6. Now let's look back across again. Well, I've got my oxygens matched up now, but now my aluminums are back off again. And so if I look at it, all I have to do is get rid of this 2, and I need to have this one come to a 4. The aluminum's by itself, so whatever I do on this side will only affect the aluminum. So aluminum does not have a subscript, so if I just simply put a 4 right here, then it becomes a 4 here. So this now is a 4. So now I'll look across. Aluminum's 4, aluminum is 4. That checks. Then of course oxygen checked earlier, oxygen 6, oxygen 6. So basically it requires me to have 2 aluminum oxides to form 4 aluminum atoms and basically 6 oxygen atoms, or you could say 3 oxygen molecules. Okay? That was a more complicated one. Okay, let's look at our next one. Okay, we have C3H8 plus O2 yields H2O, which is water, and then we have carbon dioxide. So let's count up our, or let's see what atoms we have. We have C's, we have H's, and we have O's. Okay? So over here we're going to do the same thing. Even though these are not in the same order, I still want to keep them in order. So C's, H's, and O's. And I do that so that I'm organized when I'm going back and forth. So let's count up our carbons. Over here we have 3. Over here we have we have 8 hydrogens and 2 oxygens. Okay? On this side, I have 2 hydrogens here, an oxygen there, and 2 here. So I've got to add those together. So 2 plus that 1 will be 3 oxygens. And then we have 2 carbons. That 2, I'm sorry, just 1 carbon. That 2 does not affect the carbon. So 1 carbon. So as I look across, 3, 1, 8, 2, 2, 3. This one is all mixed up. So remember, I can only go up with my numbers. I can't go down. So let's look at the lower numbers and try to make them match up to the higher numbers. Well, let's start off with this really big bad boy right here. We have 8 hydrogens. We only have 2 here. So let's try to get that 2 to work up to 8. Well, that hydrogen's attached to the subscript 2, so I need to find a number times 2 that would equal 8. Well, 4 times 2 equals 8, so I want to try that first. Okay, so that changes my hydrogen to an 8, but my oxygen is also now affected. So the oxygen is now a 4. Remember, there's a little invisible 1 here, so 4 times 1 is 4. So I could write that down if I want to. But I also have two oxygens here, so that's actually plus 2. So I actually have 6 oxygens. My hydrogen, or my carbon did not change because I never put a coefficient here. So just to refresh, 4 times that 1 is 4 oxygens. So I have 4 oxygens. Here I have 2 oxygens. So 4, 5, 6. Okay, that's what happened there. Now look across. 3, 1, 8, 8, 2, 6. Let's try to get that oxygen over there to go up to a 6 for a second and see what happens. Okay, so now I look and I say, well, what can make that a 6? Well, I can put a 3 here. Oops. Not wanting to grab. Okay, let's just go ahead and write it in. Okay, 3 times 2 is 6. Okay, now look across. 3, 1, 8, 8, 6, 6. My carbon's a problem. My carbon here needs to go up. But if you notice, my carbon here is attached. So what would happen? Let's just see what would happen if I put a 3 right here. Okay, so 3 times that C is 3. But that also changes my oxygen now. So my oxygen now is 3 times 2 is going to be 6 oxygens. and then I have that 4 here, so 6 plus 4, so I got 10 now. So I got 3, 8, and 10. Okay? So if I look over here, can I make this oxygen a 10? So I can erase this. I can erase all that right there. So if I make that oxygen a 5, now it's a 10. 5 times 2 is 10. It didn't affect my carbon or hydrogen because it's separated by that plus sign. So now I'll look across, 3, 3, 8, 8, 10, 10. That matches. So that one is a balanced equation. This one took a little more time, just kind of going back and forth and back and forth. Now what I want to do is take this moment to pause my camera, and then we're going to go to my desktop on my computer, and let's take a look at some example problems you guys can work at home and on your laptops here at school. So we'll go to that, and then I'll be right back with you, okay? Okay, what I'd like to do is talk to you a little bit about the website that can help you practice some of these balancing equations problems. If you will go to my website, www.hpisd.net, and you will click under Middle School and go to Faculty. So I'm going to click there real quick. Okay, it's going to bring up the faculty here at Highland Park. Click on my name. And once there, I would like you to click on periods 2, 5, 6, and 7. Okay, you'll notice these boxes on this page, or these folders, that indicate some of the links that you can go to on other websites. I'm going to open the folder that says Links to Useful Sites. Once you click on that, you're going to see this Balancing Chemical Equations. Click on that. Now, I would like you guys to start with, let's just say 5 beginner balancing equations. So once you do that, click on Ready to Start. Okay, for example, I'm just going to look, and there's a drop-down menu right here, which gives me from 1 to 9. That's basically the coefficient. What number would I put right in the front of H2O? So what number could I put there to make it balance? Well, one thing I'm looking at is I've only got hydrogens and oxygens that I'm concerned about balancing in these beginning equations. So I'm going to look and try to figure out how many oxygens, or let's go with hydrogens first. So this 3 times this 2 on the arrow. So right here, that big 2 times that 3 gives me 6 hydrogens. But if I look over here, here's a unique situation. We haven't seen this yet. The 2 subscript here doesn't just affect the hydrogen, it affects the oxygen in parentheses also. But right now I'm just kind of interested in looking at my hydrogen. So right now I've got 2 hydrogens, but it's multiplied times that 3. So 3 times these 2 here, okay, is 6. And then if you notice over here, I had 6 also. So I have a total of 12 hydrogens. Well, on the right side of the arrow, I need 4 hydrogens. Well, there's no hydrogens over here. I've only got hydrogens to look at here. So this subscript 2, what times 2 would give me 12? Well, 6 times 2 will give me 12. Now, I'm not too concerned about looking at my oxygens because I just want to see, hey, for a random chance, will that work? So I'm going to check my answer. And it did work. So obviously, if I would count my oxygens right now, it would also balance. So let's go to the next one. Okay, this one, it's got H2O, so a water molecule. And I'm looking at this, I'm looking at my reactants over here. And if I notice, I've still got a parentheses problem here, which means that 2 affects everything in the O and the H. And so what I want to do is go ahead, let's count up the O's this time. Okay, that O is affected by this 2, so basically I have 2 oxygen atoms right here. But it's also multiplied by this coefficient, which is 3. So I essentially really have 6 oxygens in this part of the reactants, okay? I also have 4 oxygens here, but don't forget they're multiplied by this 2. So I have 8 oxygens over here. Okay, so I had 6 plus my 8. So I have 14 total. So here I just have my hydrogen or my oxygens over here. So right now that's just a 1. Here I have 4 times this 2. So I have 8, 9. So I'm trying to figure out what I need to get it to work out to 14. Okay, so if I have 9 here, I need 5 more oxygens. So there's no coefficient here, so if I just put a 5 right here, so let's kind of think about that. 5 times the 1 oxygen would be 5. And then I have 4 times 2, so that's 8, plus that 5 is 14. So let's see if that works out. I messed up. So let's see where we messed up at. Sometimes these do get a little challenging, just kind of working them out through your head like that. Let's try the hydrogens. Let's just see what's going on there, because the hydrogens look like they may be a little more simpler. Okay, so let's take a look right now. Let's go back to the reactant side. H times 2 is 2. Okay, so that H times that 2 is 2. But we also have this 3, so that makes it 6 hydrogen atoms. Over here, I have 3 hydrogens times the coefficient 2. So I have 6 there. So 6 plus this 6 on this side over here are going to end up being 12. So if you notice, there's no hydrogens over here. So this is really an easier way to go. So what times 2 would be 12? Let's go 6. So let's check my answer there. Okay, so let's see what we did wrong with the oxygen. So obviously I messed up with the oxygen. So let's go back and look at that. So with the 6 being correct, we have 6 oxygens here. We have 4 times this 2. So we have 8 plus that 6. So we have 14. So I must have miscounted. Let's look over here. So 14 is our magic number. So here is 4 here times that 2. That's 8. Then I have the O affected by the 2. So that's 2 times that 3, 6. So that is 14. So that makes it 14. So it's just a mathematical problem there. Anyway, you can work through each one of these problems. You can go to the next one and so on. But once we go back, let's say if we go back to the original website, once you get done, I want you to check 10 or 5, either way you want to go, and practice doing the intermediate. The advanced are very, very challenging. So you're welcome to do those as well. Once you finish looking at this website, you're going to find that it shows you how many attempts it took you to do each particular problem. I would suggest and encourage you to go ahead and write these things down and work them out instead of doing them through your head like I just did. Had I written it down, I probably would not have made a mistake before I answered. So try to avoid doing any mistakes. Try to get it right the first time you attempt it, okay? Anyway, great practice. Tomorrow we'll be working on a worksheet that actually has you do these for yourself. It will be for a grade. So get as much practice as you can before you have to do the worksheet, okay? We'll be working on this some in class today. I'd encourage you to work at home. If you have any questions, please let me know. Come see me in tutoring. Feel free to drop a comment on the website or on the YouTube channel and let me respond back to you. Okay? Thanks a lot.